So for grouped data, we will use the formula Q3 equals LQ3 plus into bracket 3n over 4 minus CF3 divided by FQ3, close the bracket and then multiply that by C. It's important that we understand what these different components of the formula represent. First, LQ3 represents the lower class boundary of the third quartile. And then N represents the total frequency of the distribution, while CF3 represents the cumulative frequency before the Q3 class, that is the class to which the quartile 3 point falls. And then the C here represents the class width, while the FQ3 represents the frequency of the third quartile class. So let us look at this example. If we are interested in calculating the semi-interquartile or the interquartile range for this distribution, first we will need to compute the cumulative frequency, because remember, somewhere here we will need the cumulative frequency for F3 for quartile 3 and then also for quartile 1. We will also need the relative frequency. The relative frequency will help us, particularly the cumulative relative frequency will help us know where the different quartiles fall. Don't forget, Q1 is 25%, Q2 is 50, Q3 is 75. So we're interested in Q3 in this case. If we want Q3, then we'll compute this relative frequency column. To calculate the relative frequency, just divide the frequency, in this case 8, by the summation of the frequency. So if you say 8 divided by 50, that gives us 0.16. Here we will say 14 divided by 50, that gives us 0.28. And so after doing that, if we like, we can convert that to percentage by multiplying whatever we get by 100. And once that is done, then we can now compute the cumulative relative frequency. Here we have 16 as the relative frequency, 16% for the first class. Now, to know the cumulative frequency, relative frequency, we will add this 16 to 28, and that gives us 44 here. Here it is 68, because we will add that 44 to 24, and then add also 68 here to this 18 to get 86. So if we are talking about the Q3, we know that our Q3, that this class is our Q3 class, because the class before it accounts for up to 68% of the cases. So it accounts for up to the 68th percentile, but not the 75th percentile, which is what we are interested in. So our interest is in this class. So we will ask ourselves, what's the lower class boundary there? The lower class boundary here is 30.5. Add that to 3 into 50 divided by 4, and then minus 34. Where did we get 34? 34 is the cumulative frequency before, that is, before our Q3 class. Don't forget, this is our Q3 class. The cumulative frequency before that is 34, and so that's why we have 34 there. And then we will divide that by 9. 9 is the frequency for our Q3 class. Our class interval, our class width is 10, so we will replace C with 10. So if we solve what we have here, our answer will be 34.4. So that's our Q3 points. We will do the same thing for Q1. Q1, don't forget, is 25%. The first class accounts for up to 16%, or the 16th percentile. The second class contains our Q1, because the 25th percentile will be found in this class. So for that reason, we will say that our lower class boundary is 10.5. Add that to 50 divided by 4, and then subtract 8. Where did we get 8? 8 is the cumulative frequency before that class, which is 8, and then divide that by the frequency for our Q1 class, which is 14 in this case. So when that is done, we will have this answer here, 13.7. So our interquartile range is actually, like we said earlier, Q3 minus Q1. In this case, our Q3 is 34.4 and our Q1 is 13.7. So our interquartile range is 20.7, and the semi-interquartile range is 10.35, because if we divide 20.7 into 2, we get 10.35. Also, we can compute the 10 to 90 percentile range. The 10 to 90 percentile range is the difference between the 90th and the 10th percentiles. So to find this, we will need first to find P90 and then find P10. Look at the example we have here. We have ungrouped data here, and we need to find the 10 to 90 percentile range. To do this, we have found the relative frequencies for all the values. Because this is ungrouped data, our frequencies will be 1 for every observation. So the relative frequency for 43 will be 1 divided by the total number of observations. In this case, we have, let us count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So if we divide 1 by 25, we get 0.04. And so this way we can also compute the cumulative relative frequency column. Now, having done that, we will see that our 10th percentile, our P10, falls here, because the second value, 54, accounts for up to 0.08, or say up to 8%. Now we're looking for the 10th percentile. So the 10th percentile in this case will be 56. Okay, then our 90th percentile will be 98 because 96 accounts for up to 88 percent. Okay, so this way we have determined P10 and P90. P90 in this case is 98 and P10 is 56, and so 10 to 90 percentile range will be 98 minus 56, which is 42. So that's how to calculate the 10 to 90 percentile range. Now we will move on to the variance and standard deviation. The variance is the average of the square distances between the values and the arithmetic mean of the distribution. The standard deviation is the square root of the variance. And we should state here that the standard deviation is the most commonly used indicator of dispersion or spread. A standard deviation of 0, for instance, means that all the values in a distribution are identical. That is, there is no deviation from the mean of a given distribution. So for the standard deviation, for the variance, we will use the formula summation into brackets x minus x bar raised to power 2 divided by n minus 1. Then to find the standard deviation, and you will use this formula if you're dealing with an ungrouped data. To find the standard deviation, you will find the square root of your variance as this shows. So let us look at this exercise. Find the variance and standard deviation of these scores. The scores are 2, 3, 4, 5, 6, 7, and 8. So first, we need to find our x bar. Don't forget, x bar represents the mean. And to find the mean, you will add up all these figures, all these observations, and divide by the total number of observations, which is 7 in this case. So adding this will give us 35. If we divide that by 7, that gives us a mean of 5. Now, we need to subtract the mean from every observation. The first observation is 2. So I need to say 2 minus 5. That gives me minus 3. 3 minus 5. That gives me minus 2. 4 minus 5. That gives me minus 1. 5 minus 5 gives me 0. 6 minus 5, 1. 7 minus 5, 2. 8 minus 5, 3. So I'll also need to now square all these values. So if I say minus 3 raised to power 2, that gives me 9. Minus 2 raised to power 2 gives me 4. Minus 1 raised to power 2 gives me 1, and so on. At the end, I will add up all these values, that is 9 plus 4 plus 1 plus 0 plus 1 plus 4 plus 9. That gives me 28 there. So I'll now divide 28 by 7 minus 1. That is n minus 1. So that gives me 4.667. To find my standard deviation, I will find the square root of 4.667. That is 2.16. Now, if I am dealing with grouped data, the formula changes only slightly. So for the variance, I will use the formula summation f into x minus x bar raised to power 2 divided by n minus 1. And to apply this formula, I will need to first find a class mark for each class. So here I have 1 to 5. The class mark will be 1 plus 5 divided by 2. That gives me 3. The class mark here will be 16 divided by 2, that gives me 8. This is 26 divided by 2, that gives me 13, and so on. So after that, I'll also need to find my mean, and for that reason I'll need a column for fx. Fx simply means f times x. 6 times 3 is 18. 9 times 8, 72. 14 times 13, 182. 5 times 18, 90, and so on. So my summation fx is 385. So to find my mean, I will divide 385 by 35. So that gives me a mean of 11. Now I need to compute a column for x minus x bar. So x in this case is 3, and x bar is 11. So 3 minus 11 is minus 8. This will be 8 minus 11, which is minus 3. 13 minus 11 is 2. Then 18 minus 11 is 7. 23 minus 11 is 12. So I'll also need a column for x minus x bar raised to power 2. So to do that, I simply say minus 8 raised to power 2. That gives me 64, minus 3 raised to power 2 gives me 9, and so on and so forth. After doing that, I will multiply the values in this column by f. So in this case, I'll say 6 times 64. For the next one, I will say 9 times 9. That's 81. And then here, for the third group class, I'll say 14 times 4, and so on. So when I'm done, I will calculate the I'll sum up all the values in this column, and that gives me 910. And so to calculate my variance, I will divide 910 by 34. 34 is n minus 1, that is 35 minus 1. That gives me a value of 26.8. In some contexts, it really doesn't matter, particularly when you're dealing with a very large sample, if you subtract 1. And so it's possible that in some books, you'll see n as the denominator and not n minus 1. But if the sample size is large enough, it's not going to make any significant difference. But for the purpose of this course, we will be dealing with n minus 1. And so now that we have our variance, to calculate the standard deviation, we simply find the square root of 26.8, and that gives us a standard deviation of 5.2. So we will also need to be familiar with the coefficient of variation. The coefficient of variation is the ratio of the standard deviation to the mean. So we actually use the coefficient of variation to compare variability, or to compare variation in different data sets. So it makes it possible to compare variation in a particular data set with variation in another data set, particularly when the unit of measurement is not the same. Okay, so it's a measure of dispersion that shows the amount of variability relative to the mean. And the coefficient of variation, like I said earlier, makes it possible to compare variations of different data sets. So, and the formula is the standard deviation divided by the mean. So if you have these data sets, for instance, we used these data sets earlier. If we are to calculate the coefficient of variation, we simply divide the standard deviation, which we calculated earlier to be 5.2, by 11, which is the mean. So that gives us a value of 0.473, or if we like, we may convert it to percentage. So that gives you a coefficient of variation of 47.3%. So if you have a question that says you should compare two data sets and determine which one has greater variability, like what we have below. Okay, so this one says which one has greater variability between height and weight given the data below for students in a class. Okay, so in that class, the mean height is 66 inches while the standard deviation is 4 inches. And then the mean weight is 69.5 kg while the standard deviation is 4.1 kg. Now, just looking at these two sets of data, if you compare directly, if you will want to say that there is greater variability in weight because the standard deviation, which measures variation or dispersion or difference from the mean. So if you look at weight, it has a standard deviation of 4.1, while height has a standard deviation of 4. But we cannot compare them directly because they have different they're using different units of measurement. Okay, so the right thing to do is to calculate the different coefficients of variation and then compare these coefficients of variation. So to calculate the coefficient of variation for height, we will say 4, which is the standard deviation here, divided by 66. That gives us a coefficient of variation of 6.1%. And then for weights, we have a coefficient of variation which is 5.9. So by implication, there is greater variation or there is greater variability in height than weight. So that negates that initial thought that we have greater variability in weight. So these are the major measures of dispersion that we will be talking about in this course. I hope this class has been helpful, and I wish you the very best. Make sure you do the assignments